Another thing that's very important when we're thinking about sound and or light or waves is called diffraction. What is diffraction? Diffraction is the bending of light around obstacles. So, you know, like how we said refraction was light going through one medium to the next? This is the bending of waves around, not light, just any wave around a medium. So I'll give you a little bit of physics background. The amount by which the light diffracts depends on the wavelength of the wave itself and the size of the object. So I want you guys to try something. Maybe we can try it. So if can we do pairs of people? Can everybody become a pair? Like, can we all pair up real quick? Okay, so stand with your backs to each other, facing back to back. Okay, can you see each other? But say something, say hello. So back to back, say hello. Do you all hear that? Okay, now I want you to move 2 steps away. Okay, do you still see each other? But say hello. Do you hear that? Can you also pick out the person you're trying to hear? Okay, do you recognize what's going on here? Light, now turn around. Now say hello again. Is it louder than before? Now turn towards each other. Oh, sorry, you were supposed to turn this way, towards me. Both of you turn towards me and say hello. Okay, is it louder than before? Yes, now I want you to turn towards each other and say hello again. Is it louder than before? Good. What does that tell you? That tells you that sound diffracts more. You are now the obstacle in the path. When you were away from each other, your head was the obstacle, right? As you have removed the obstacle, so now turn back to the front again, both people turn to the front again and say hello again. You are still the obstacle. You are not talking in the direction of the other person, but sound is still spreading. So you hear it better. Now if you turn away from each other, say hello. Is it worse? Is it getting worse and worse every time you increase the obstacle? However, if you notice that you don't see the other person, and there's a reason, yes, you're an obstacle too, but the other reason is that light wavelength is very small. So it doesn't go around obstacle. You are an obstacle. Light will not cross you. But sound does. The sound has a longer wavelength. The amount by which it's going to go around you, obstacle, is high. Right? Thank you. That is diffraction. The bending of light around an obstacle. Okay, so now let's put some more physics into it. Huygens did a lot of studies with waves. And he said that I'm going to define waves as tiny wavelets, tiny wave fronts, as light propagates, composed of spherical wavelets. As light or as a wave goes forward, the wave fronts maintain what they're doing and the tiny wavelets go alongside them. Now, why is that important? That is important when we are looking at obstacles in the path. Don't worry, it's going to come up again and again. It's okay. So if you see an obstacle in the way, do you remember that our little wavelets are here and the wave fronts are going here? What do you predict will happen? What will happen to these wavelets? They will be stopped. Good. What happens to these wavelets? stopped. What happens to these three in the middle? They'll go forward, right? That's what Huygens said. Now, what happens on the other end if I have a situation like this? What happens to the middle ones? What happens to the end ones? Continue forward, right? Absolutely. This is the case when the obstacle is much larger than the wavelength, much larger than the wavelength of the wave. On the other hand, what about an obstruction that is very close to the size of your wavelength? Can anyone predict what will happen here? And it's okay, you can write this down, imagine it in your head. You would think that they would go like this, right? What they actually discovered was that the wave actually bends around the obstacle. And that phenomenon is called diffraction. And it allows you, so have you ever, I don't know if anybody's noticed, but you will notice it now. Open the door slightly to a very small hinge and see the sunlight coming through. You will notice that the sunlight is actually bigger than the obstacle that you left it at. Or the rays that come down from the clouds, you'll notice that they kind of spread as they come down. That's because of diffraction. Light actually bending away from the obstacle. And vice versa, what will happen in this case? That. So how does that help in our sound wave situation? In sound waves, usually what you will notice that you will hear men's voices more than women's voices if you're trying to hear them from either far away or around an obstacle. And the physics reason for that is women's voices are usually higher pitched, higher frequency, will not travel around the obstacle better. Men's voices carry because they have a longer wavelength, because they have lower frequency. So high-pitched sounds tend to be more directional and they don't diffract much. Low-pitched sounds, usually like those of the adult males, have longer wavelengths and will be diffracted around corners. So you will hear men around corner better than women. Okay, diffraction also has its issues, and one of the biggest issues is how do you soundproof a room? Diffraction causes sound to bend and diffract and spread. So when you want to soundproof something, you have to make sure that it's sealed way more than just the source of sound. So that is why it is very difficult to make those soundproof rooms where there's no sound. Like really hard to do. Okay, and as always, because we are in a physics class, we have to have an equation. So the relationship for finding the frequency in sound intensity with a slit with the width W is sine of theta equals lambda over W. Or when you have a circular opening, the formula changes to sine of theta equals 1.22 lambda over D. If you have like a uniform width, use this formula, basically like this, there's a slit. Or if you have a circular opening, use that formula.